Hi, I'm Ray, G4NSJ. I'm going to tell you how to use this for checking out common mode chokes, tuned circuits and crystals. Quite a few of you might have a bag or a box of crystals, quartz crystals. I've got a box full somewhere covering what, 6.6 megs medium wave. I can't think what that lot were for. Anyway, moving on swiftly. Basically, we're going to use both ports. When you check SWR, you just need channel 0, okay? So you'll just need one. I've made up a croc clip lead there, you see, like that. In fact, I've made up two. Now, there's a close-up picture of those. So that's checking SWR and antenna resonance. When you want to do things like common mode chokes, crystals, tuned circuits, you will need both these ports. Now what I did, I showed you, I made those up, but I've also made up this little box. These are the two leads to the NanoVNA. And here I've got a couple of crocodile clip leads. You're going to say, oh, these are too long. Not for what I do. This is for tuned circuits, crystals, that sort of thing. Checking common mode chokes. This is where you need the two ports. I'm not using this up in the gigs. If we're talking about the gigs, then these will be several wavelengths long. Well, not quite. It depends how high you go. I'm talking about HF, you know, medium wave, HF, shortwave. I'm not even dealing with VHF because I'm an HF man. So this is ideal for tuned circuits, HF aerials, bits of wire, quartz crystals, all that sort of thing. So there it is. That's my little box I've made up. If you're going to use leads like this, the two braids you will clip together and use those to go across your crystal tuned circuit, or the braid of this. So braid there and braid there, all right? That's how it is. That's one other reason I made up the box, because these are obviously, the outers are connected there, so it just gives me these two. And the way to do it is on the braid there and on the braid there. So that is the setup, not the inners, just the braid, right? Once you've wound your choke. I've done previous videos about this, about making it, and the results on screen about crystals and tuned circuits. I've got an old superhet radio from the 40s, connected these two leads up to that, to the chassis, and you can see the aerial circuit, the oscillator circuit as you tune around. I've done all that, but I haven't in those videos actually told you how to use the VNA. So that's the kind of arrangement. Look at that. And also I thought that looked rather professional, that box. A bit better than that arrangement. Right, so let's get rid of these. Now, fortunately, when we set this up, okay, for common mode chokes, for example, you're going to set it up for that. That setting is also good for determining your crystal frequency, because bear in mind not all crystals are marked, and tuned circuits. So if you've got a tuned circuit, for example, recently I've made up a ferrite rod for a vintage radio, made up a ferrite rod variable capacitor, and I just put that tuned circuit on these two leads, and up it all comes on the screen. Now I've set it, I think you'll see when you do this sweeps across other frequencies, right? So I've set it from, I forget now, you'll see when I do it. I think it was 1 meg to, was it 100 megs? Or no, 1 meg to 30 megs, that's it. Because I'm only really interested in HF. So I've set the sweep from 1 meg to 30 megs. This is for HF, okay, the shortwave amateur bands. Top band to 10 meters. My crystals here, crystals don't go above about 50 megs anyway because they get too thin and fragile. So again, that's between 1 and sort of 30 megs. Okay, without further ado, do you like my little radio? Look, got that from a friend of mine in Australia. Without further ado, let's have a look at this. Let's have a look first of all how we set it all up. That's the important bit, setting this up. So connect two leads to the NanoVNA. When I say connect the open circuit, you know, you've got these in your kit. One of them doesn't have a little pin in it, connect there. Okay, you'll need the little coupler to do that. Then the short circuit, that's the one with the pin in it, and then the load. Okay, that's the silvery colour one. So that's what I'm doing. To start with, we'll go to stimulus. So there's stimulus. Okay, start, and we'll start at 1 meg. 1 M for meg. Back here, stop, 30 megs. That's that. Next thing to do, go back to the display. We want the blue trace. There it is, there's the blue trace. There. Back. Then calibrate. Now before we calibrate, press reset. I always do that because it just resets whatever's in there from its memory last time. Then calibrate. Now this is where we start connecting things to the lead. So calibrate. I'm now going to connect the open circuit little adapter, little screw on end stop. This is on channel 0, so I've done that. I'm now going to connect the short circuit on there. Done that. I'm now going to connect the load. This is all channel 0, and I've connected the load. Done that. Now isolate. I'm now going to connect the load to channel 1. All the others were on channel 0. The load on channel 1. So I've done that and pressed that. Now join the two leads together. You get a little coupler in the box. That's through. I've done that. You then click done, and you can save that in one of these. Now I've saved it already in 0, and that's what you'll get when you've saved it, just the straight line, the blue straight line. So we're now ready to check the common mode choke. So what you should have had is that arrangement, channel 0. So that was, what was it, open circuit, short circuit, load, then the load on this one, and then for the through one, the coupler like that, joining them together. Okay, so I'm now going back to this arrangement, connect these two right to your NanoVNA, and then the braid and the braid. All right, that's that arrangement. Connect all that up, and we'll see what happens next. Little wheel on the top here goes left or right to change the frequency. At the moment we're on 1.87 megs. 24 dB attenuation there. There we are. Move the little wheel. I'll just do the amateur band, so let's go to 3.6 megs, 27 dB. Let's go on to the 5 meg frequencies. There were 5.35, 28 dB of attenuation. Let's go on to 7 megs, 29 dB. You can see what I'm doing, can't you? 10 megs, 30 dB of attenuation. This line here is covering the HF spectrum. Okay, 1 to 30 megs. Let's go to 14 megs, 20 meters. There we are. 30 dB. 18 megs, 30 dB there. 21 megs, 29 dB. For 12 meters we're going to 25 megs because it's just below 12 meters, isn't it? 25. So there we are, 25. 29 dB, and then 29 megs for the middle of the 10 meter amateur band. 28 dB. Right, tea break. We're now going to take this off and stick a crystal on it. Yes, so the whole thing about the NanoVNA is, this is just brilliant. You might see a design for one of these, you might order the choke, the correct type choke and your number of turns. You've no idea. You just stick it up on your aerial at the base of, whether perhaps your dipole is, you stick it there and just hope that it's doing something. You don't know. You might want less turns, you might want more turns, you just don't know. You can see now how easy it is to actually look on the screen and see what's going on, rather than just, oh well, I've sort of done it as it said in the article, or as a friend of mine said to do it. Let's hope it works. Okay, we're now going to connect the crystal. I've got to connect all this up again. Connect the crystal between those two. Or if you're using, leads like this, as I said earlier, connect the two braids together, and the crystal goes to the two inners, all right, on each port. Okay, what we're going to do is recall 0. That's where I stored it. So we've got the 1 to 30 megs. Okay, let's have a look here. I can't see anything here. Let's go up in frequency. There's a little blip there. Can you see that little blip? Let's see where that is. Hang on, there's a blip there first of all. So we need to stretch this out. The crystal is somewhere in there. So there's a little blip there and there's a little blip there. So let's change stimulus, start. Let's go 1, just out of interest, 1 meg and stop at, say, 10 megs. Right, now, I don't know whether the lighting is very good for this. Can you see that? There's something there. Let's move the little marker there. And that is saying 4.960 megs on there. So let's open this out again. So we know it's around 5 megs. Okay, so let's start at 4.5 megs. And let's stop at 5.1 megs. Now look what we've got here. This is looking better. That's saying 4.9. Let's move this again. Let's start at 4.9 megs. Now we've got it in the centre of the screen. So you see how I'm doing that? Now the little wheel on top, move that marker, see that marker? Move that marker up here, up to the top, and it says 4.998 megs. Well, I happen to know this is a 5 meg crystal. That peak at the top there is series resonance. Okay, if we go down here to the trough, that says 5.008 megs, 5.008. That's parallel resonance, series resonance. And of all my crystals I've checked, I have found the series resonance is the one stamped on the crystal case. In this case 5 megs, so I've got 4.998. Now before I forget, you could change, as you saw, you recall location 0 for example, where I've got 1 to 30 megs. I've got that stored, as I told you, for this sort of thing, for making up loop aerials like this. Alright, this is for medium wave, ferrite rod aerials, checking crystals, all sorts of things. You can change it. As you saw, I stretched it out. I went from, it was 1 to 30 megs. You can narrow it. If you think your crystal's around 10, do 9 to 10 megs. Start at 9, stop at 10. It'll then sweep between those two frequencies, looking for the crystal. Now, just be careful with crystals. Some of them work on what they call the overtone. It's not a harmonic, well, yeah, you call it harmonic, it's not really strictly true. The third overtone of this is 5 times 3, okay? So 3 5s, 5 megs, 15 megs. And that's what I'm about to show you. Some crystals were made to operate on the third, 5th or 7th overtones. They work better on odds for some reason. I don't know all about crystals, so no good asking me. If this crystal, this one is designed to work on its fundamental frequency of 5 megs, because as you will see, the overtone, the third overtone at 15 megs is it's a lot smaller. Okay, if you find that you've got a crystal, say you've got a 15 meg crystal, and you found it on there, your 15 megs, 3 15s are 45. Okay, if you find that that's a bigger one, it's meant to work on that bigger one on the chart, on the graph. So it's a third overtone crystal. With crystals, just very briefly, I won't bore you, with crystals, they only manufacture them up to about 50 megs. I mean, I'm going back a few years, it might be different these days, because the material, the quartz material, above 50 megs, becomes so thin and delicate that it's just going to break up. So what they do is make a crystal and then use it on its overtone. Also, take an FM amateur radio transmitter, for example, FM transmitter.
rather than have a crystal, or rather than try and get a crystal 145 megs for 2 meters, what they do is use a much lower frequency, and then in the radio multiply it. So you might have a 10 meg, double it to 20, have a trebler to 30, and so on. What that also does, nothing to do with the VNA really, but I'll just tell you, FM deviation, frequency modulation, if you try and do it up high on your sort of final frequency, for example, band 2 VHF FM broadcast band, the DEV is 75 kilohertz. That's a lot. So do it down low, do it on say a 5 meg crystal, the deviation is going to be a lot smaller. Very easy to do. Anyway, that's all beside the point really. I don't know why I mentioned that. I just thought you might be interested. So yeah, a couple of tips. Well, I'll tell you the tips afterwards. Have a look at this, the third overtone on the 5 meg crystal now.
Sorry about the reflections on the screen. I've now gone up because, do you remember there was another little blip? So I've now gone up from 14.8 to 15.5 megs. And there is the blip. And if we look at that, 14.975 is the series resonance there. That will be the third overtone. So that's interesting, isn't it? When you're doing your short circuit, open circuit, load and all that, if you're going to use these leads, put the load and the short circuit things on there. Don't do it on the NanoVNA itself, do it on the leads, because then it takes into account the lead length and capacitance and inductance and all that. Ideally, connect the leads there and put the load, open circuit, short circuit there. Really, I would need a little SMA connector there to do it, but well, not between those two, no, between there and there. Anyway, yeah, as I said, I'm on HF, medium wave HF. I'm not too bothered about a little bit of a reading, because I've got a little bit of lead there, you know, it doesn't matter to me. Obviously, as I said earlier, if you're working up in the gigahertz, then that sort of thing is just no good at all. Right, I made some notes. I can't read my notes. Yes, so you might find a crystal. If you've got a box of crystals, just have some fun, you know, to spend the afternoon as it's raining. It is raining, playing about with the crystals. If you find ones on 15 megs, it's just arbitrary figures. 15 megs, you might think, oh yeah, it says 15 megs on it, and it's 15 megs. Go down to 5 megs. Go down to what might be the fundamental, just out of interest. See what it says there. Right, is there anything else? Have I bored you enough? I always worry with these videos, not that I bore you, because I know you're never bored with my videos. I just wonder whether I've explained it all properly. You know, whether you've got it all in here, because I'm not always that good at explaining things, but hopefully you've grasped what I've sort of been saying, how to use this. A lot of local radio amateurs have bought these. I think just about every one of them have bought these, and several of them have said exactly what I have said. I bought this just for SWR and checking aerials. It was only when I started looking into it that I thought, hang on a minute, you know, I can check that. I can check a tuned circuit. I can check a loop aerial, a ferrite rod. You know, I can make up a little box like this. I can check crystal frequencies. There is so much, and I believe there's so much more that I haven't even looked into yet. So that little box, if, as a lot of people do, you've bought it for SWR and aerial resonance, that sort of thing, have a look further just to see what else it could do, and you'll be pleasantly surprised. Okay, I think that's enough. Oh, by the way, one last thing about that. If you vary the number of turns, you can look all this up online. You can perhaps make this work better down the low frequency end of the shortwave spectrum or wherever. I wanted to try and get an overall thing. I'm not too worried about top band. That's where it wasn't so good, if you remember. So you can do that. Okay, that's it. What's these notes? That doesn't mean anything. Mum, mint. Oh yeah, my mum wants some mint. Okay, on that note, thanks for watching as always. Hope you've understood that. Oh, just one last, I must tell you this. I was using this the other day and I forgot. I had to watch my own YouTube video to find out how to use the damn thing. Take care. Bye for now.